In this video, we will cover what happens when you have a complex zero, and I want to find the remaining zeros of the function. Okay, so normally what I would do is I would do P over Q with 60, and I would probably synthetic divide. But you are given a zero of the function, albeit it's a complex zero, but you are given a zero nonetheless. So if 1 plus 3i is a solution, therefore 1 minus 3i is a solution. And I'm going to find the function that gives me this solution. So I'm going to do b over a is the opposite of their sum. Which is -2. You can do the box if you want. You can do distributing if you want. However you want, good, go for it. 9 minus 9i squared, that's 10. Minus 9 plus 1, 10. Okay. So the function that gives you the solutions, 1 plus 3i, is x squared minus 2x plus 10. However you find that function's up to you. Okay, well, I know the quadratic that gave me these two solutions. Fourth degree, there are two solutions left. So if you want to do P over Q, that's fine up until right now. If I give you a complex, you need to demonstrate that you know how to find the remaining function. You can't synthetic divide two answers and they're imaginary on top of that. I do think that there is a way to synthetic divide with imaginaries, and it gets a little bit complex, haha. And if you want to synthetic divide with imaginaries, go for it. You should get zeros. X squared, that gives you x to the fourth minus 2x cubed plus 10x squared. That's negative 5x cubed plus 4x squared minus 38x minus 5x. Remainder better be 0 or we messed up. Let's see, 4 minus 10, negative 6x squared plus 12x minus 60 minus 6. Okay, perfect. The remainder better be 0. So now there are two zeros left, quadratic. You have two zeros, a quadratic, quadratic. The two quadratics give you x to the fourth, x squared minus 5x minus 6, x minus 6, x plus 1, x equals 6 and negative 1. This means that by synthetic, negative 1 would have quote unquote worked. Then you would have to keep plugging in. 6 would have worked. It would have left you with x squared minus 2x plus 10. You would have used the quadratic formula and gotten 1 plus or minus 3i. So in total, 1 plus 3i, 1 minus 3i, negative 1, and 6. In this next problem, I'm just going to ask you to solve it, which is what you've been doing. And then I'm also going to ask you to write in factored form. X cubed plus 13x squared plus 57x plus 85. It is a cubic. It must have at least one real zero. It must have at least one real zero. Look at Descartes. There are no sign changes, which means that that one real zero is not positive. This is how you are going to save yourself tons of time with synthetic. P over Q. 1, 3, 5. I don't know off the top of my head. 18. What's 85 divided by 3? Oh, 85 doesn't divide by 3. Okay, I cheated, went ahead and figured out the factors without the video on. So I'm not going to bother plugging in 1, 5, 17, or 85. I already know there's not a single positive zero, but there has to be one real. It's not positive, therefore it must be negative. So try -1. So you look at this problem and you think, oh my gosh, 85. 85 is better than 12. 85 has fewer factors than 12 does. -1 isn't going to work. And I'm pretty sure -5 does work. X equals -5. So honestly, that's not that bad. Now I have x squared plus 8x plus 17. This problem is no different than what we've been doing with P over Q. It is imaginary, the discriminant is negative. B squared minus 4AC all over 2A. So this is -8 plus or minus 64. -4 all over 2. This is -8 plus or minus 2I over 2. So my other zeros reduce and you get -4 plus or minus I. Okay, those are the solutions. You can factor with imaginary numbers. You can factor with imaginary numbers. So these are the solutions, the zeros, the x-intercepts. Factors. So if x equals -5, x plus 5 is a factor. If x equals -4 plus I, then x plus 4 minus I is a factor. If x equals -4 minus I, then x plus 4 plus I is the factor. So in factored form, x plus 4 minus I, x plus 4 plus I. These are the factors. Know the difference. If you multiply x plus 4 minus I, x plus 4 plus I, you're going to get x squared plus x plus 17. Multiply the whole thing out, and you're going to get the given polynomial. Just want to do a quick side note about factoring with fractions. So let's say you do a problem and you get x equals 1 plus or minus 2I root 3 over 5, okay? You have some quadratic, you factor it, or I'm sorry, you solve it, and this is your answer. So these are two complex solutions. Notice they come in a conjugate pair. And I ask you to write this as factors. So if you're asked to write this as a factor, you get 1 plus 2I root 3 over 5. and x equals 1 minus 2I root 3 over 5. So you don't just subtract the whole fraction, etc. No. Multiply by 5. Subtract 1, subtract 2I root 3. So as a factor, this is 5x minus 1 minus 2I root 3. Multiply by 5. 5x equals 1 minus 2I root 3. So your other factor is 5x minus 1 plus 2I root 3. So that's just a side note about how you're supposed to properly multiply or write as factors when your complex solution involves, roots and all kinds of things.